All right, what's on the bench? It's a big box from RAHAM. It is a radiation hazard meter. Now, I've been looking for one of these for a while. It's made by the General Microwave Corporation. This is like the gold standard for measuring radiation, electromagnetism that might do bodily harm. And so there's a bunch of specifications written on how much RF energy can leak out of things, and they all use a particular meter from RAHAM as the gold standard for measuring that in how much radiation is coming out. So I bought this for $65, and let's see what's inside. All right. So we have, let me make sure everything's on camera here. It's kind of hard to photograph this. So this is the meter that I bought. I already had this meter, so this one, like I said, I've been looking for one of these for a while, and I bought this meter thinking that I would get it working someday, and I never did. So anyway, it's in the video today, but I'm not going to be using it. I'll be using this meter. So let's just take it out. Little handheld thing. This is the model 481B. I know this is a 481C because I have a user manual for that. And it measures milliwatts per square meter, or square centimeter, milliwatts per square centimeter. And yeah, so it's pretty simple. It's got some gain settings, full scale 2, 20, and 200, and then has an on-off switch, and it has a battery check button, and that's the bottom here, so my batteries are good. So first of all, let me talk about the batteries. Let me see if I can find one of the old ones. Of course, the batteries were dead. Unfortunately, it uses these, they're alkaline batteries. The part number is a PC133A, and these aren't cheap. I paid $16 each to get the meter working. So these batteries are $16 each. They're 4.5 volts. So if you were going to own one of these, I probably would replace it with a lithium type of thing. I don't know. Anyway, batteries are expensive, but I do have it up and running now. So I'm into the whole thing for $100. So it comes with some antennas. All right, here's an antenna, and up here is an antenna. Okay, so we're going to use this one today. Take it out. It's got this little cone thing here. We'll talk about that. But yeah, this is the model 82, and so you attach it to the device like this, and then you have this pointy thing. It's like a magic wand, and you go sniff around with it, right? So let's see here. Let's move this so I don't destroy things. Move the camera down a bit. Okay, so I'm going to turn it on, and first thing you do is check the battery, and then put it on the most sensitive range, and then zero it. Okay, so we're gonna zero it. All right, and then here's some RF energy, and we'll put it next to the antenna here, and then you can watch the meter. Let me turn the radio on so I can transmit, and here I'm gonna transmit, and oh, there we go. Ooh, that was way too big. I got too close to it. Let's see here. Oh, there we go. Okay, so let's put it down to the 20 range, and I'm having trouble with my fingers here. There we go. So we're measuring about 0.25 out of 20. So yeah. So it does measure. And yeah, it's interesting. So we're going to talk a little bit about how this thing works. And it has to do with this magic antenna. So you might think, as I did, that this thing is just going to be kind of an antenna, and there'll be a diode detector, crystal detector, to measure the RF amount of power. And that's not how they did it. So if you've ever heard the term bolometer, this is more of a bolometer, okay? And so a bolometer works by absorbing the RF energy into heat and then measuring that. And it's usually done with resistors. So as the resistor heats up due to the RF energy, it's in a bridge circuit, and that bridge circuit then outputs a voltage because there's a differential with the resistance changing with RF energy, all right? And so we are lucky in that let me show you the other. So a couple other things in the box here. Let's go back down to the box. There's a cord, so you can remotely do the antenna thing. It's an extension cord for the antenna, and there's another bigger antenna here. But let me talk about this meter, which I purchased some time ago. Look at that, nice big meter. It's the same thing. It's got ranges to 200 to. It's got all the same stuff. Push to 0, response time, normal, slow, peak. This one has peak and averaging. There's a cal factor. The cal factor, it comes with cards for the antenna. So the 82 and the 83B, which is the other one, here are the cal factors for different frequencies. So if you know the frequency you're operating at, you can dial in the cal factor. So that's kind of fun. So I had purchased this just dirt cheap a long time ago, and I just thought it was a cool looking thing. I thought maybe I would repurpose it into something. And but I needed the antenna. I didn't have an antenna. So I went onto eBay and I found like a $30 antenna, and I bought the antenna, and I bought one of these, okay? And I went to plug it in, and this connector and this connector are not the same. This unit uses a completely different connector, completely different antenna. So the antenna that I had would not work in this unit, okay? So now I have two of these antennas, and what does that mean? Well, we can tear it down. All right, so the antenna that I received was this one. It had the numbers and everything on it, which is pretty cool. So here is the antenna. It goes something like this. There's a connector on this side, middle section, this tube that goes out to the antenna, and then at the end is this piece of styrofoam, and this piece of styrofoam contains the antenna. This is really the whole trick. So we will take this under the microscope, take a look at it, talk a little bit about this this fancy antenna and how it works as a bolometer. All right, here's the insides of one. I've already taken it all apart. So on this end we have the screw-on connector, and we have the calibration resistor here. We've seen that on the schematic. There are a couple wires, and then finally there are these two wires, the red wire and the black wire. That's actually the sensor. That goes to the front of the sensor. So that's really where it gets its signal from, right? So that's in a tube here. You can get to the adjuster through a hole here. All right, and then it goes. This kind of went in there, just a bushing. But here are the red wire and the black wire that attaches here. It goes onto a PC board. Now this PC board is interesting. It has what looks like deposited resistors on it, okay? And I think we need to measure those. So let's measure those now. All right, let's see if I can do this with one hand. I'm gonna touch one end of the PC board here and one end over here, and I know you can't read it, but it's 36.7 kilo ohms. All right, I've got one probe on this end and one probe on this end, and it's 38.73974. 38.74 kilo ohms along the PC board here. So interesting. So I think that's part of the bridge circuit. Not really bridge circuit, more of a, well, anyway, more of a voltage divider, I think. Then there is the business end, okay? Zoom out here a bit. So we've got the business end here, which is the cone. And the cone is there to isolate the sensor from infrared radiation, from heat. You don't want it to get hot. So this cone, even though you might think it's a fancy shape for RF, no, it's to isolate the sensor. And where is the sensor? Well, the sensor's inside, so I've cut open. The foam is actually poured in here. It's actually molded in, so I had to actually break it apart. So here is the sensor, okay? And we can pull it out, and it's much different than I ever thought it was going to be. All right, and so, yeah. So let's take a look at this under the microscope. It's got a connector here that pushes onto the PC board like so. All right, and so here under the microscope you can see the gold contacts there that mate to the PC board. And then there are two insulators, two dielectrics that are held together with little plastic screws, nylon screws. And when you open that up, it's a sandwich, and inside the sandwich are two very, very thin, flexible PC boards that have traces on them. One of the traces zigzags back and forth in a vertical direction, and one zigzags in the horizontal direction. So very, 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 very interesting. So I have found a patent that describes this particular sensor. So we'll take a look at that. Let's look at a couple documents. I found this patent, 1976, and it is for the antenna, all right? So this should look familiar. These are the little standoffs on the dielectric, and then here's the crisscross of the horizontal and vertical antennas. It gets all sandwiched together. All those little thin layers are sandwiched, and we saw that. So here is the construction. It looks exactly like the one that we have. Here's the way that it wires in. This is where it makes electrical contact, and it comes out, and it's at an angle so it doesn't interfere. And anyway, let's see. Here's the theoretical equation for frequency and how it operates. Yeah. So anyway, if you're interested in learning more about how the antenna works, it is patent number 3931573. All right, that'll tell you all about it. But in the user manual, all right, we can see some schematics that might be more interesting. All right, so here is a probe, and this isn't exactly the probe that we have, but it's similar. Here's the connector. Here's that calibration resistor, a 5K resistor, just hanging over on the antenna ground. And then there is some capacitors. I think we saw that on the long 38K resistor. So it was a capacitor on one end, a capacitor on the other end. So that's these two capacitors. They're 0.022 microfarads. And then the kind of the bolometer type part is over here. It's kind of drawn as some diodes. But so that's what that looks like. And then here is what the pinout is. But let's take a look at how the machine works. Let's see, I know there's a schematic for the machine. Here it is. All right. Zooms in. There we go. So the bolometer thing sits here, so that there's a signal that comes into here, and then there's some buffer amplifiers here and here, high impedance coming in. There's some offset adjustments here to zero it, and then it goes through some gain, and it runs into this differential amplifier, which looks at the differential voltages due to the change in resistance, and then it outputs it to a meter. So it's a very, very, very simple circuit. All right. So we can look inside the meter itself. I'll show you some photographs here. You can see there's the two batteries, and then there's all the electronics in a can. And if you open up the can, you see basically a quad op amp in there that does everything. And yeah, high quality components, I would say. All right. Anyway, that was the video for the day. I'm going to have to find some dangerous things to go around. It really needs quite a bit of energy for it to be registering. Like I just kind of walked around the house looking at things that I thought might be spitting out a little bit of stuff. But this thing's looking for things that are dangerous, not things that just happen to be maybe interfere with a radio. This interferes with your body. So it's looking for higher doses of radiation.